Object-oriented programming, or OOP, is a powerful programming paradigm that allows you to structure your code using objects and classes. In this section, we'll explore the core principles of OOP in Python: classes, objects, polymorphism, inheritance, abstraction, encapsulation, and iterators. These concepts help you build modular, reusable, and scalable code. At the heart of OOP are classes and objects. A class is a blueprint for creating objects, defining their attributes, or data, and methods, or functions. An object is an instance of a class. Here, dog is our class. Dunder init is a special method called the constructor used to initialize new objects. Self refers to the instance itself. Name and breed are instance attributes, unique to each dog object. Bark is an instance method. Species is a class attribute shared by all instances of the dog class. Inheritance allows a new class, or subclass, or derived class to inherit attributes and methods from an existing class, or superclass, or base class. This promotes code reusability. Here, cat inherits from animal. Super dunder init calls the constructor of the animal class. The speak method is overridden in the cat class to provide a specific implementation. Polymorphism means many forms. In OOP, it allows objects of different classes to be treated as objects of a common type. This is often achieved through method overriding, as seen with speak above, or by having functions operate on objects regardless of their specific class as long as they have a common interface. Even though duck and dog are different types, make sound can call speak on both, demonstrating polymorphism. Python achieves polymorphism naturally through its duck typing. If it walks like a duck and quacks like a duck, it's a duck. Encapsulation is the bundling of data or attributes and methods that operate on the data within a single unit, i.e., a class. It also involves restricting direct access to some of an object's components, promoting data integrity. In Python, there's no strict private keyword. We use conventions like a single underscore for protected attributes or a double underscore for name mangling, which makes attributes harder to access directly from outside the class. This encourages interaction through methods like deposit and getBalance. An abstract class is a blueprint for other classes, containing one or more abstract methods. Abstract methods are declared but do not contain an implementation. Subclasses must provide an implementation for these abstract methods. We use the ABC, or Abstract Base Class module. You cannot create an instance of an abstract class directly. This ensures that any class inheriting from shape must implement the area and perimeter methods. An iterator is an object that can be iterated upon, meaning you can traverse through all of its elements. In Python, objects that implement the iter and next methods are iterators. The iter function returns an iterator for an object, and next retrieves the next item. When there are no more items, next raises a stop iteration exception. This is how for loops work internally. Time for our OOPS concept quiz. See how well you've grasped classes, objects, inheritance, and the other principles. Pause the video and try to answer. Solutions are next.